All right. In this video, we're going to be talking about section 1.3, part 1, and we're also going to introduce you to your graphing calculator. For those of you who have acquired the TI-83, TI-84, or other TI-84 family of graphs, graphing calculators, then what we talk about here will be pretty relevant. So please follow along even if you don't have your calculator yet, because this is something that you will eventually need to know how to do. All right. We're actually going to use that in just a minute. We're not going to use it for this warm up, but we will be using it probably starting on example 2, and we'll see what happens after that. All right. So let's just go ahead and get started with the warm up. As usual, pause the video and try this on your own. And here we go. This is a piecewise function. Piecewise functions are confusing to a great many people. I'm not one of them, so I'm having a real hard time figuring out why people struggle with these so much. I think it just has to do with maybe forgetting or just not paying attention to the details. I don't really know, but let's see if we can make heads or tails of this. I think I need some graph paper here, so let's turn that on. All right, a piecewise function is simply saying that we have, kind of like we talked about the union, joining two sets of numbers together as one set. That's kind of what we're doing right here. We're taking two different, what seem to be two different graphs and functions, and we're merging them together as one whole graph. But it has two distinct parts. And here it says that, and the way we read this is we look at the right side of these first. So I'm going to look right here. This is talking about the domain. And you'll notice that between these two statements, we have all real numbers. We have either greater than or equal to -1, or we have less than -1. So everything's covered. And so what this is saying, we'll go with the less than first. So that's on the bottom, you'll notice. So for all the x's less than -1, we're simply doing the function f of x equals 2. So again, as long as you're plugging in something smaller than -1, then we don't care about the piecewise function. We just care about this equation, f of x equals 2. That's what this says right here. F of x equals 2 for, or if you like the word when, that's better, when x is less than -1. So when x is less than -1, like for example here at -2, it says the output's 2. And everything less than, they're always going to be 2, including all the way up to -1. But when I get to -1, it's not there because we're not plugging in the value of -1. We're not plugging it in to get this answer of 2. Because now we're plugging in values of -1 and greater. So that means we're focusing on this function instead, this portion of it. So now all I'm talking about is graph this function, -x squared plus 4, which hopefully we know is an upside down parabola starting up at 0, 4, 1, 2, 3, 4. And then I know that it's going upside down. So I'm going to go over 1, down 1. I would normally go over 1 and down 2, but I'm not going to do that point because that's a value that's less than -1. And this function that we're doing is only valid when for x is greater than -1. So I'm instead going to focus my attention over only on this side of it, down 3, down 5. And so I get a graph that looks something like that. All right. Use interval notation to express the domain of the whole thing. So all of the domain has an answer. Even -1, the output is up here, not down below. And so I would say the domain are all of the x's such that they belong to the group -infinity to infinity. Range. Range is telling me this is going down forever. We go all the way up to a height of 4. and we start coming down, there's this gap here, but it doesn't matter because we have those y values over here. So the fact that there's a gap, the fact that this always stays at 2 doesn't change anything, right? Because we're just saying what y values are present in the problem. And I see y values that belong to the group from negative infinity all the way up to 4, including 4 not negative infinity. Okay, let's now let's go ahead and practice and learn how to use our calculator. So this is one we don't need to use our calculator on, but let's go ahead and practice here. So let's familiarize ourselves with our calculator. Let's get to the main screen. Okay, so hopefully this is being recorded and you can see it on the side of the screen. When you start and turn on your calculator, it should be on this window right here. This is where you can do your, your basic math and get your answers, etc. But we want to focus our attention for graphing. We're going to do most of our work up here. So let's just kind of go through a quick little inventory. If I hit the y equals button, this is where I can record, or I'm sorry, this is where I type in the formulas, the equations I'm going to be graphing. Okay, we'll do that in a minute. If I go over to Window, this is where you can, if you want to, set a minimum and a maximum window. In other words, you're telling it what size of window to show. Usually I don't mess with that very often. Go to Zoom. There's all kinds of different zooms you can do. You can zoom in and out, decimal and square. Obviously, I don't really use most of those. Zoom standard is a big one that kind of resets you back to this is what it, if you don't tell it what to do otherwise, this is the zoom it would do, zoom 6. Number 1, I didn't talk about. That's the box zoom. That's you drawing a box where we want the window to be, and I'll show you all that. Trace isn't going to show us anything yet because we don't have a graph. And then graph is where we then tell it to graph. Okay, so let's plug in the square root of x minus 4, this function. And so from here, I'm going to turn on and do the square root. And I'm going to, depending on how old it is, you might want to open in parentheses, or it might have opened a parentheses for you. This version for me is going to actually kind of type it in the format that it thinks I want to see. So the variable x, you'll see this button right here next to alpha. This is the variable button. And depending on what mode you're in, it's going to put in the right variable for you. We're in rectangular mode. It's going to give you an x. And then I'll do minus 4. And then you'll notice it's all under the square roots, right? If you have an older model, you would now want to close the parentheses to end the square root. But you could also, in this case, probably just leave it alone. Okay, let's just jump over and graph it now. Okay, didn't see anything. Let's figure out if there's a mistake or if this is expected. And honestly, it feels a little mistakey to me. But before I panic, I'm going to do something. I'm going to go to Zoom, and I'm going to go to Standard. So I'm going to hit 6. Aha, and there it is. The issue is that my window is not showing me a window where this thing existed. All right, so let's take another look through here. Honestly, you're not going to use a lot of this. You're going to go to Trace if you want to, but this is not very helpful. And you can just sort of, it's moving the x's. In fact, that's outside the domain, so it's not even there. Now it's showing y values, right? Because now we're within the right domain. So if you're just curious about what some of these points are, there they are. But that's not a very efficient way of looking at your points. So trace is not something you really ever need to use. Let's go back and look at graph. It turns off that trace button. All right. If we go to table, so I'm going to go second function, and then up here to table, to graph, second function graph. The table currently is set for, it's just going to give me increments of 1, and it's giving me all the inputs and outputs. It's giving me an error because these are all imaginary answers until I get to 4. And now I've got all the different Y values right here. So that's a little annoying because oftentimes I want to be in command and control of what numbers I'm plugging in because I might want some decimals in here. And so what I'm going to do is I'm going to come over, since we're talking about the table, I'm going to come over to table set. So that's second function above window. So second function window, I have table set. All right. So this is where like your table is saying it's going to start at 10. And the change in your table is going up by 1. So if you wanted to go up by a half, you could change that, or by 0.1, you could change that. But none of that's really going to be very helpful. What you want to do is change just your independent variable. It's on auto. This is what creates the automatic 1, 2, 3, 4, 5 on the left side. So we're going to change that to, oops, too far, to ask. So I'm going to hit enter, and now it's on ask. And now when I go back to table, or you can hit graph, whatever you want to do to get rid of that. When I go back to table, second function table, now it's empty. But now if I want to know what's going on at 4, I can just type in 4. If I want to know what's on at 4.1, I can just type that in. Okay, so I get to be in charge now of what goes in. Okay, nice and simple. All right, so what were we being asked to do? Find the domain and range of this graph. So we would have wanted to graph it. There it is. If you don't like the window it's showing you, kind of like we saw before, you can do a zoom. And let's practice the box zoom. So I'm going to either hit 1 or hit enter. And now you don't see anything, but if I use my up and down arrows here, you'll see I have this little plus sign bouncing around. So what this allows you to do is pick where you want your window to be. So I don't want to see all this nonsense out here at -10. So I'm gonna hit enter to set the corner of a box. I'm gonna scroll down, set the next corner. I don't want to go negative very far because I know that there are no negatives. And now I'm going to move over because I want to focus on this part. I'm going to hit enter. So now it changes and shows you that box instead. And this is honestly where you're going to get yourself in trouble because you're going to be done with this graph. You put your calculator, you come back and you put an equation in and it shows you like nothing like we saw at the first when I started this. And that's because of the last time you used it, you changed your window. So then you have 2 ways you can fix it. One is you can go back to manually set your window. Right, so this is saying the minimum X value, the maximum X value. That's the left and right side of your screen, the scale change, and it shows your Y values as well. But that's a pain. So we want to do that. Let's just reset by going to zoom and then standard, zoom 6. And now we're back to the traditional look. Okay, zoom in is kind of annoying because you can't control it as well. If we go to zoom in, I hit number 2 here. It's telling me like I can set the sort of the center point. And so it's not horrible if you take the time to like, okay, I want to look in this area, and now I'll hit enter. So it zoomed in there, but you don't have a lot of control. So I don't really like using zoom in or zoom out. Zoom fit. Let me scroll down. It's going to be like zoom 0, zoom 0, zoom 0, zoom fit is pretty handy if you have a specific X values you're interested in. So for example, I can go over to my window and I can say, look, I know this thing doesn't exist below 4. So I'm going to say, I want to see from 3 and I want to go to 15. But I don't know what the outputs are, right? So I don't know what the Y values are that I want to plug in. I just know I'm really interested in this domain. So if you have the X values set the way you want them, and then you go to zoom 0, which is zoom fit, it's going to calculate the Y values that are in that range, and then it's going to set the Y value for you. Okay. So this is handy, but also is very problematic because what you're going to notice is like the difference, my Y value window, I can't even tell what it's set at. I don't even know where my X and Y axis is. And if we go back to window, we will see, it's not necessarily doing what I thought it was going to do. a y max of 3. I would have expected it. Oh, yeah, I guess that makes sense. So I told it to go to 15, right? Well, if I plug in 15 to my equation, I get 15 minus 4 is 11. And the answer of the square root of 11 is around 3 something. So it went ahead and calculated what it thought was a good window to show me. All right, Zoom 6. Back to where we started. Okay, find the domain and the range. We know the answer. The domain is obviously from 4 to infinity, all the x's that belong to that group, and the range would be all the y's between 0, including 0, and infinity. Okay, so let's get back to math. Let's set the calculator aside for a moment, and let's continue here. Example number 1, use the graphs from today's warm-ups to determine on which intervals the function is constant, when it's decreasing, and when it's increasing. So the two functions we had were a and then this b. And so let's go back and look at the piecewise function that we graphed. So to be constant over an interval is hopefully pretty obvious. It means that the y value is not changing. So as you move from point to point, usually we talk about moving from left to right. So as x gets bigger, what's going on with the y values? So we can see that from the interval starting at negative infinity and going all the way until we get to -1, the y value doesn't change. So for part A, I would say that it is constant, and let's use interval notation, from negative infinity all the way to -1. When is the function decreasing? So again, decreasing is going to be talking about specifically as we move from left side to right side, what are the points doing? Are they going up or are they going down? And so it looks to me that we have peaked up here at this spot right there. And then we start going down starting at 0. We are answering this as a domain question, like from this x to this x, the points are going down. And so I think we can hopefully agree that it's going down, starting at 0 and going all the way to positive infinity. In other words, starting at 0 and then moving this direction, that's when our y values are getting smaller. So I think we're going to say that we're decreasing from 0 to infinity. Now, I don't want to get too deep into this, but at an individual point, we're not increasing, we're not decreasing, we're not constant. At an individual point, we're doing nothing. We're just sitting there. When we're talking about increasing and decreasing and staying constant, we're looking at what's happening over time as we change. And long story short, every time we answer this question, it's going to be an open interval, okay? Because endpoints aren't doing anything, right? If I look at just at any individual point, even if I'm just looking at this point right here, at that point, and that's the only point I look at, nothing's happening here. It's just a point. To answer about increasing and decreasing, I have to compare it to the ones around it. So, long story short, when I'm talking about trying to answer what's happening at 0, that's not a question we should be asking ourselves, because at 0, it's just a point. What's happening? When is it changing? It is changing starting at 0 to infinity, and it's an open interval. We'll talk about it again. Increasing and decreasing, you're always going to be open intervals. And then increasing, looks like we're increasing only in this little interval right here, and that would be from -1 to 0. Starting at -1, we start rising, and then we get to 0, we stop rising, and we turn around. All open intervals. Let's look at part B. Part B is still on the screen over here on the left, and it looks like we're constant, never, right? We're always going to be changing, going up or going down. So not, so there is no interval. When is it decreasing? It's never decreasing. When is it increasing? From 4 all the way to infinity, not including the 4, not including infinity. And I suppose we should be saying for all the x's in this element or in this set. But again, I don't want to beat this to death too much. I just want you to be prepared to use the right language when you have to. All right, let's keep going. Increasing, decreasing, constant. All right, let's take a look at our calculator and let's get this thing graphed. So if you don't have a calculator and use Desmos, please do so. But why don't you pause and graph this thing? All right, so I'm going to plug it into my calculator. I'm going 2x to the, so I'm going to use this guy, right? 2x cubed, the little caret symbol. And now, depending on your calculator, you need to put just the 3 in parentheses, x cubed. In my calculator, it formats it correctly, but you'll notice I'm still up in the superscript. And so I'm going to hit, and where'd it go? There, over button. And now I've moved over, meaning I've moved out of that superscript. 2x cubed, write it down right, yep, plus 3 variable. And I'm going to square the variable. So I can either use the caret again, the hat, or I can come over to the x squared button, and it does it for me. Minus 12x. I don't know what I last graphed it as, so again, what I would do is probably get used to not hitting the graph button, but just go right to zoom and hit 6. All right, so now I've got myself a nice window. I can kind of see what's going on with the graph, I hope. And I already knew what to expect because it's an x cubed graph. So I was expecting some version of this. All right, so then what is this question asking? It says, locate any relative maximums or relative minimums. So we talked about increasing and decreasing, and I think I better change my window a little bit here. So I'm missing the top half of this section. So I'm going to just do a zoom. I'm going to do a zoom out and see how much I hate it. So I'll just zoom out from the center. Oh yeah, I hate it, right? Because it zoomed out consistently. So now that I've done that though, I think I can do a zoom box and kind of get what I want to see here. So let's move my cursor. I'm going to come down enough to catch the bottom, of this guy right here. And then I'm going to go up. So I'm going to hit enter to set that corner. And that's probably good. I'm going to go high enough to grab that top piece. And then I know it's just going to keep getting bigger. In fact, I'm going to go back down. There we go. All right. With my numbers there, with that kind of trace in the way, it's kind of there. Okay. All right. So I can tell that this graph is going increasing from negative infinity all the way up until whatever the x value that leads to this high point. And then I can tell that I'm decreasing from this high point to this low point, right? So those x's. And it looks like I'm increasing everywhere else. So between an increasing, right, going up and going down, you have a point. And this point right there, even though it's not the maximum of the graph, it is the maximum of the points around it. So if you were to take and draw any kind of open window around this, so if I zoomed in right here, we would see that there is a single point that is the highest point. All right. It's not the biggest in the graph, but it is the biggest in this little neighborhood that it lives in. All right. We wouldn't say this one here in the middle is the biggest because in its neighborhood, there's one that's bigger slightly next door, right? So it's only here. It's like, oh, wait, if I look on both sides of me, now they're both smaller. So relative maximum. Relative minimum would obviously be down here. And so our job is to figure out what those are. They're located at an x, and then their maximum is the y value. They're located at an x, and their minimum is the y value. So the relative maximum occurs at what x and then what's its value. So here's where we can learn a new little function. We can either use the trace feature and kind of guess, or we can let the calculator do our thinking for us. So I'm going to go to calculate. So I'm going to do a second function above trace, so second function trace. And right there you'll see there's lots of things you can figure out. You can calculate when is it 0. That's going to be helpful for us. When's it a minimum, maximum? That's today. When do graphs intersect? And then some calculus stuff. So we're going to calculate, let's do this maximum first. All right, so it's not smart enough to give you the answer because there could be 5 or 6 maximums depending on where this thing turns at. So what it's now asking you to do, you'll notice it says left bound. So this is telling us, hey, move the cursor to the left of where you're confident, like to be to the left of the maximum. So I'm going to scroll over, and then it doesn't have to be perfect. You can go well past, right? So I'm well past on the left side of where I think there's a maximum. So I'm going to hit enter. And then it says, where's the right side of where you want me to look? So I just got to scroll and make sure it's between there. I'm going to hit enter. And now it says guess. Now you don't actually have to guess. It just wants you to now scroll. I'm just going to go one back to put me within the window where I'm looking. I assume the closer you are, the faster it'll be, but you'll notice it's instantaneous. All right. Now we got to not trust what we see. We got to trust our brain. I hope we all agree that the calculator is not perfect, but it is telling us something here. It is telling us the maximum is not at negative 2.000. There's little math errors and rounding all the time. We're going to interpret that, obviously, at negative 2. And the y value is 20. So the relative maximum is y equals 20. And it is occurring at x equals negative 2. And I'm perfectly fine you telling me that the maximum is at negative 2, 20. Don't confuse this with an interval, right? It's not an interval. This is a point. It's happening at negative 2 and the maximum is 20. So the minimum, second function, calculate, down to 3. You can either hit 3 or scroll to it. And now, same as before, go to the left. Okay, we're on the left side of a minimum. I'm going to hit enter. Scroll far enough to get over. Notice I'm putting no effort in worrying about it. Scroll back into the middle and do our guess. 0.9999. Hey, guess what? That's 1. So at x equals 1, the minimum value looks to be negative 7. Or you could just tell me it's at 1, negative 7. Okay. Now we're going to just kind of put all that together and answer everything we can about a function. Okay. So function negative x cubed plus x. What's the domain? What's the range? Increasing, decreasing, constant. Any relative extrema. That's the plural that talks about minimums and maximums. All right, pause the video, do some investigating, and let's see what you come up with. All right, so let's go ahead and graph this thing. I'm going to go to y equals. I'm going to hit the clear button to get rid of the previous one. By the way, if you're like, hey, I know I'm going to need this function again, I want to come back to it. So let me just put like a function here, a very boring function here. You'll notice that the equal sign is highlighted. That means that's the active graph, right? So maybe you wrote in this really complicated formula, but you don't want to look at it right now, but you know you're going to need it again. What you can do is you can scroll down and do a different graph, right? Let's do x squared. Okay. And now they're both going to graph, right? Because they're both highlighted. There they are. But if you only want one of them to show up without deleting it, you can just scroll over and you could hit enter and unhighlight the equal sign. So now only the second graph is going to graph. All right. Let's get rid of that and get back to work. Okay. We're doing negative. Make sure you use the negative button, not the minus button. It will give you an error. Negative x to the third. Scroll out of the superscript or close your parentheses and add x. I'm going to do a zoom 6. That's pretty much what I was expecting. Can't quite see them in a maximum. I know it's there. I don't need to zoom in to answer this question, but my perfectionist in me is bugging me. So I'm going to use a box. I'm going to scroll over. I'm going to go up. Good enough. Enter. Scroll over past all the good stuff. And then scroll down. Make sure capturing the specifics. And there we go. All right. The domain, we know all of the x's that go from negative infinity. That's bugging me. I can do better. All the x's that belong to negative infinity to infinity. The range, or all the y's that belong to negative infinity to infinity. When is it increasing? It looks to me to be increasing from this low point to this high point. So I need to know what the low point and the high point are. And by the way, that's going to answer part F. So if you want to jump down here and do part F, we certainly can. The minimum looks to be occurring at, second function, calculate, 3. By the way, you can also type in a number here. So if I want to know, like, looks like we're like -2. So I can jump over. Notice it set my left bound. And I can type in 0. That's on the right. All right. So it's given me these little symbols telling me here's where we're looking. Scroll back to the middle, hit enter. All right. We're going to round to 3 decimal places, I think. So the minimum is at -577 with a y value of -385. All right. So that tells me, well, let's go ahead and calculate. That's not what I meant to do. Calculate the maximum. Scroll over a little, hit enter, scroll over or type a number. And the maximum is at 0.577. Looks like this thing is symmetric. 0.384 positive 85. All right. So now let's look at this. When is it increasing? It is only increasing on one interval. From the x, that's the minimum, to the x, that's the maximum. So that's going to be, it's increasing on all the x's. Which x's? The ones that are in the group -0.577 to positive 0.577. When is it decreasing? Well, it's decreasing from negative infinity to that low point. So it's going to be decreasing on all the x's that belong to the group negative infinity to negative 0.577, which is where it started increasing again. And then it's going to start decreasing again. So I'm going to join it with the group 0.577 to infinity. And when is it constant? Never. And honestly, most of the answers are going to be never. You would not say it's constant at the high point because that's an individual point. Increasing, decreasing, constant is about intervals, not about individual points. Okay, I think that's all we're doing today, which is a lot. I think the video ran a little long, but hopefully everything makes sense and you now know how to use your calculator.